Teaching science. Now, my first reaction to any title like that is the same as those students, is sort of yawn, yawn. But actually, I should have to give you a little, tell you about my prejudices. But first your reading assignments, okay? Here's some books I think everybody who's interested in the world should be familiar with. First of all, great book, written about 15 years ago by Robin Wright, Non-Zero. The references to zero-sum games and how what the human race has learned to do in about the last 15,000 years, 10,000, 15,000 years, is to play a non-zero-sum game with itself, in which if you've got something good that I want, it's actually better for me to make something good that you want and trade with you than doing what sort of the first animal impulse is, run over and take it from you. Anyway, a great book, and I recommend it highly. Next, Steven Pinker, Milton's, wonderful book to read. You read the newspapers today and you think, oh my God, these human beings, you know, what terrible animals they are, killing each other in all these terrible ways. But actually, step back and take the long view of history, and we're getting better. We're getting better. There's actually been less violence over time. Hard to, what, 20th century? Nope. Actually less violence over time compared to what we used to do. That's Steven Pinker's book. And finally, Virginia Pastrell, The Future and Its Enemies. I won't say much about that, but another great book. And a couple of websites for you. If you want to cheer yourself up, you read the headlines of the newspapers and think, oh my God, what are they doing now? Well, go to humanprogress.org and look at the actual statistics, of how the human race is getting better. Or another one, Rational Optimist. These are easy to remember, Rational Optimist. Or finally, good old Bill Gates. That one in particular, the latest annual letter of the Bill Gates Foundation, gives you some facts on poverty. Is it getting worse, or is it getting better? Are we eradicating poverty, or is the world getting more and more poor and unequal, et cetera, et cetera, et cetera? I won't go into that. Just let Mr. Gates talk for me. Okay. I'm going to give you my prejudices. Science and sanity. Well, in my view, science is sanity. It's the concentrated essence of the sane way to approach the world. So my prejudices, and one of my heroes for the 20th century, the man who was the first spokesman for the standing up and the liberation of China, his slogans were science and democracy. And by the way, it's been my experience that if you're against one of these two, you're also against the other. No logical connection, but just there's actual connection. So my prejudice is I'm all for the internet and television and GMO foods and rockets and space travel and all those good things, vaccination, e-books, and globalization. A lot of problems, I know, a lot of problems. Yeah, we can make nuclear power, we can make nuclear bombs, but we're going forward. Man is both a creator and a destroyer, but he's more of a creator than a destroyer in the long run. These are just my prejudices. I'm not asserting these as scientific facts, but so you'll know where I'm coming from. Anyway, I think we are headed toward, we're not there yet, by many generations away, toward becoming, as someone said, the subject instead of the object of history. So, since it's the scientists and the engineers and so on who drive things forward, okay, with the help of businessmen and all that, I'm not putting them down. No, not at all. Although I do have to say, I tutor kids in science, and it's been almost invariable case when I get a really bright one, and I think, oh, she could become a great geneticist, or he could become a physicist. You know what they all become? Bankers. We need bankers, I understand, but anyway, okay. Okay, now we don't do it very well. I won't go into this, but there have been lots of studies of the beliefs of young people about science. And not just any young people, these are kids who're taking physics courses at university, and often when they survey people with bachelor's degrees in physics, they still retain, they can pass the exams, they know the equations, but many of them, a significant number, retain the incorrect views, well, what we sometimes call naive physics. You know, things like heavier things fall faster than lighter things. That's the sort of the paradigm case of a naive physics view that's not true. But so there is a problem in teaching physics. It's been known for 30 years. Anyway, I won't take your time with that. Okay. Hopefully the only cliche I use about language, two-edged sword. It's how we have to teach. We use language, but boy, is it a powerful and dangerous thing. And I'll just give you an example of the power of language in teaching. This is not directly related to semantics exactly, but it's pretty close. Pretend that you're in the first session of a physics class, and I'm assuming that most of you have forgotten your physics, and Herr Dr. Lukas, Sie dürfen schweigen sein. Okay, but the rest of you, okay. Now suppose you're my class. In fact, I think I'll actually do this exercise. Okay, for real. I'm going to say to you, now, okay, starting, I want to know how much I need to actually teach, so let's see how much physics you know. Right, that was my reaction too. Fear, oh my God, I'm going to be exposed. One word will make the difference. Let's see how much physics you already know. Now that one word has to reflect a different approach to teaching. You know, namely not, aha, how ignorant you are, but golly, you actually know a lot already. You know, we're going to refine it and bring it out. But that's just one word, and it makes an enormous difference, because when your adrenaline is up and you're afraid of being exposed, you're not ready to learn. You know, learning has to be something that's fun, you know, that building your confidence. Oh, golly, I'm smart, and I'll get smarter. Okay. Now, here's the problem with teaching science, especially physics. The best, when you really understand something, you can compress it down, okay, into unambiguous language, which we can express as equations. And, you know, these are some of the great equations of physics. And Dr. soon-to-be Lucas will recognize, you know, all of them. And I've left out Schrodinger's equation and so on because I just didn't have room for it. But there they, oh my God, okay, something's gone wrong. With little boxes, there are Greek letters. Okay, never mind. On my computer, I have the fonts, and this computer doesn't have the fonts, I guess. I don't know. Anyway, so there you are. That's essentially what you're doing when you're teaching physics. You're teaching, well, one of the things you're doing, most important things, you're teaching kids to understand what these things actually mean. But it is such a temptation, okay, to teach the equations and how to manipulate them, all right? And I'm a tutor. Kids bring me their homework to do. And so often I have seen what I'm going to show you in a minute. Now, what's the problem? Well, it's quite possible in language to teach, to have a sentence that's completely meaningful to me. And this was a challenge Professor Anton threw out yesterday. He said, well, is it possible to make a statement that you understand completely, that's, you know, grammatical, it's with familiar words, but that no one else can understand? And I thought, well, actually it is, and I've got one for you here. If you're a linguist, shh, don't spoil it for the rest of us, okay? Some of you will be familiar with this one. Because here's the statement. I've got to give you a little background on this, especially if English is not your first language. You need to know something. Buffalo, it's a North American animal. Big, it's sort of like a moose or something, big, hairy, huge thing. I think the technical correct term is bison, okay? It's a noun, okay? It's also a city in upper New York State. And it's a verb, because a buffalo is big and powerful. He can sort of push you. You can bully or coerce someone, you know, to buffalo someone into doing something. Okay, it's just a slang term. So buffalo is both a noun and a verb, and English, as many other languages, you can use a noun as an adjective. My best example for that is, what kind of fire engine is it? It's a red fire engine. I'm going to paint my house red. What color red? Fire engine red. The noun and the adjective have just swapped places. So so buffalo is the same thing. I can use buffalo as a noun, a verb, and an adjective. So here's a sentence for you. The first word is buffalo, okay? The second word is buffalo. The third word is buffalo. The fourth word is buffalo. The fifth word is buffalo. The sixth word is buffalo. The seventh word is buffalo. The eighth word is buffalo. The ninth word is buffalo. The 10th word is buffalo. And the final word is buffalo. Now that's a completely legal, meaningful sentence to me. It took me a while, because I stole this from somebody else, and then I had to read, and it took me half an hour to work before it finally made sense with reading the explanations. But it's a completely legal sentence. Now, it tells you a fact, sort of a silly, whimsical fact that's probably not true, about buffalo that live in Buffalo. Okay? And if I wanted my students to learn it, it'd be real easy to get them to memorize this sentence, because it's just buffalo repeated 11 times. What'd be easier to memorize? But they wouldn't understand it. They wouldn't understand what the fact that I'm trying to tell them that's behind this. So anyway, now on to a little elementary physics. We'll look at Newton's second law, which I'm sure you all remember is, this is a simplified version, okay, but we won't do the rate of change of momentum or something. This force equals mass times acceleration. Even high school students do this. F equals ma. And oh my God, the homeworks that I've had to do where, the kids get these little problems. The force is this, what's the mass, etc. And I start out by saying, first of all, we don't talk about what's the definition of force. They're also supposed to learn that. I say, no, force is. Just say, when do we use the word? What are the circumstances in which we use the word force? And we have a little talk about that. And then, in other words, we're looking at the territory, not the map, because the map's not the territory, as somebody said. But you get so many homeworks like this. Oh, well, what's the force if the mass is 1,000 kilograms and acceleration is, we'll talk about that in a minute too, 5 meters. All my students want to say 5 meters per second squared. And I always ask them, you ever see a square second? Square meter, yeah, I can understand that. A square second? What's a square second? No. That's 5 meters per second every second. That's the way you have to say it. Something is speeding up or slowing down or maybe swerving at 5 meters per second every second. Every second that goes by, this thing's getting faster or slower. Don't say second squared. It means nothing, even though it's mathematically, technically true. And if they do the equation, it's just multiplication. They come up with 5,000. And if they're prompted by the homework, 5,000 newtons, it means nothing to them. I promise you, it means nothing to them. And rather, how should we teach this subject? Well, first thing you've got to do is because there's lots of interesting implications here. You got to get kids used to the idea, and it has to start when they're 8 years old or 7. A lot of things are too small to be measured easily. I take a bathroom scales and I put a penny on it. It doesn't, nothing happens. And I say, well, you mean the penny doesn't have any weight? Well, yeah, we can't measure it. How would we measure it? Put 1,000 pennies on it and divide by 1,000 or something. But first you got to get them used to the idea there are lots of things that happen in the world that they're too small for us to see. Did you know that when you stand up, the earth slows down? I bet you didn't know that. Do you know that if I jumped off this platform, I would fall toward the earth, but the earth would fall toward me also? It's just a straightforward derivation of Newton's laws, but the effects are too small to see. You've got to get kids used to that idea. And then you've also got to get them used to, as early as you can, the idea of proportionality. The more of this, the more of that, or the more of this, the less of that. Long before you teach the maths or the algebra. And then you can start, then you're getting used to them. You're getting them used to this, ready and prepared to actually understand Newton's second law. Okay, which is this. That little square box should be a proportionality sign, which sort of looks like the Greek letter alpha, but sort of squooshed out a little bit. 1 minute, okay. And I do a little algebra, switch the equation around, and you teach them this. How fast a body speeds up or slows down is proportional to two things. Directly proportional to the force. The more force you put on it, a force is a push or a pull. The more force, the faster it accelerates. Obvious, right? Or, and it's inversely, I wouldn't use that word, but it's the other way around proportional to the mass. That is, the heavier it is, the more mass it is, the harder it is for a given force to accelerate it. If I'm throwing a bowling ball, I can't throw it as fast as if I'm throwing a baseball. And that's Newton's second law in a way that's easy to understand, because we're looking at the territory, not the map. We're looking at the physical reality, and they have to have a few tools to understand the physical reality. And that's the story. The more force, the more acceleration, obvious. The more mass, the less acceleration. And I've already mentioned that. And there you are. And in other words, that's the answer. And by the way, there's the translation, if you want it, of buffalo, 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 buffalo. Namely, buffalo that live in Buffalo, New York, who are buffaloed by other buffalo living in Buffalo, New York, themselves buffalo living in Buffalo, New York, who are buffaloed by buffalo living in Buffalo, New York.
Thank you.
My pleasure.